This here is the chapter 11 question. It's the related samples t-test. And go watch the other video, the overview video for the version 4 practice exam to have the clues of why this question is what it is. Okay, I've highlighted the important information here again, but if you want an explanation of the things that I'm looking for, that's where you want to go back to that overview video. All right, so I need to do the full 4-step hypothesis testing procedure. Step 1, the hypotheses. I need the alternate, I need the null. It's a two-tailed test, so that tells me what I need to know, right? It's mu d in both of them. It's all relative to 0 for this particular chapter, and it's a two-tailed test. So for a two-tailed test, the alternate is that it is not equal to 0. It could be more, it could be less, it's not 0. The null is that it is 0. Step 2 of the hypothesis testing procedure, I need that it's a two-tailed test. I'm going to need to know that it's 0.05. And then I need my degrees of freedom. My degrees of freedom here are the number of difference scores, subtract 1. So I had 13 in this question. Dr. Gill had 13 participants come in 2 separate times. She has 13 difference scores in her data. So the degrees of freedom are 12. It's a two-tailed test, so we're going to have an upper and a lower cutoff point. And I'm going to go to table B2. Okay, and I've got a two-tailed test with an alpha of 0.05, so proportion and two tails combined. I'm going to look here, and I have an alpha of 0.05, and degrees of freedom is 12. Yes, I know I just calculated it. It already escaped my brain. So 12, and I'm going to read across. A straight edge would probably have been useful here. But my critical values are plus or minus 2.179. So anything that falls out here or out here, we're going to reject the null and accept the alternate. If it falls in this middle part, we're going to fail to reject the null. Does that sound weird and awkward? Yeah, it does. That's how it is. That's just how it is. Double negative. Sounds weird. Just roll with it, okay? Step 3, we need to calculate our estimated standard error. Don't get freaked out by all the subscripts. It's an estimated standard error, S subscript M, and then there's a D to indicate that it's of different scores. So we were given the variance, so we can use this formula, okay? So the variance was 637. We had 13 participants, and we're going to take the square root of that. So 637 divided by 13 is 49, and then the square root of 49 is 7. We can now use this and calculate our t. The t value is m subscript d subtract mu subscript d divided by the estimated standard error. This mu d is 0. Okay, that's where this comes from. It's always going to be 0, but that's where it's coming from. It's coming from the, well, technically it's coming from here. It's coming from the null hypothesis. So m subscript d was 16, subtract 0, divided by, that value goes there, it's 7. So we have 16 divided by 7, which is 2.29. Okay. I'm going to use red on the off chance that you can see red, it's great. And if you can't, then it's not all that much different than demonstrating it in black. So the value I just calculated, 2.29, it's in this critical region. So I'm going to reject the null, accept the alternate. Okay. You can use this as your evidence, or you can indicate that it's in the critical region, or you can say that 2.29 is larger than 2.179. Okay, it's beyond, right? So if this here would be 0, it's further out, it's further away. Then we need to calculate this confidence interval. Okay. The formula for the confidence interval, and we're going to do the 80% confidence interval, mu d equals m subscript d plus or minus t multiplied by the estimated standard error. This t comes from table B2. That's where things will go sideways. If they're going to go sideways, that's probably where they're going sideways. So MD, that was 16, plus or minus. Now we need to find T, okay? And we go back to table B2, and if we have 80% here in this middle, then we have 20% in the tails combined, okay? So what you might want to do is, in a different color that's visible to you, you can write confidence interval. Right up there. And then proportion in two tails combined. If there's 20% in the tails, then there's 80% in the middle. If there's 10% in the tails, then there's 90% in the middle. If there's 5% in the tails, then there's 95% in the middle. This one we don't really use, this one we don't really use, and you might see this one, 99. Because if there's 1% in the tails, then there's 99% in the middle, because the area under the curve always adds to 100. Our degrees of freedom was 12, and we wanted the 80% confidence interval, so 20% in the tails. So that value there, is 1.356. I'm in red, not so useful. 1.356. And then this estimated standard error comes from step 3. We already calculated it. It's 7. Okay. So we're going to have 16 plus or minus 1.356 multiplied by 7 plus or minus 9.492. Okay. So if we take 16, subtract 9.492, we get 6.508. And if we take 16 plus 9.48, 9.492, we get 25.492. So we are 80% confident that the true value of the mean difference is somewhere between 6.508 and 25.492. All right.